Hi guys, it's Ms. Hill here again, continuing our unit on linear functions, and today we're going to talk about solving systems of linear equations by graphing. And some of these we are going to graph by hand, and then I'm also going to show you how to use your graphing calculator as a quick and easy way to come up with the solution to your equations. So just a quick reminder, systems of equations, that's when we have two equations in the same system or graphed on the same coordinate plane, and our solution will be the point, or it could be points, where those lines intersect. So we could have three possible scenarios. We could have no solutions. If the lines are parallel, they're not going to intersect, so there would be no solution. We could have one point of intersection, meaning that we will have one solution. So we would write that solution as that ordered pair as a point of intersection. Or the third option is that we could have infinitely many solutions because they are the same line. So we would say that there are infinitely many solutions on the equation y equals whatever the equation was. And you can use either one of those equations as your answer. But that's because all points are on the same line. So every single one of those points on the line, they will be a solution. So we just say infinitely many solutions on that line. So let's work through some of these. And we're going to start on graph paper, graphing by hand, using the simple methods that we used in previous lessons on graphing equations from our different forms. So starting out with our first example, we have two equations. The first one, y equals negative x plus 4. Our second equation in the system is y equals 2x plus 1. So here we're going to use different colors to represent our different equations. For my first equation, we're going to have our line drawn in purple, and we can see that we're in slope-intercept form. So we can see y equals negative x plus 4. We have a slope of negative 1 with a y-intercept at 4. So we're going to start by plotting our point at 0, 4. And then we're going to use our slope of negative 1 to count down 1 to the right one and find some more points on the graph, and we're going to connect those with a straight line. So it's going to look something like that. There's our first equation. Then for our second equation, where we have y equals 2x plus 1, I can see that my slope is 2 and my y-intercept is 1. So I'm going to start at my y-intercept of 0, 1, and then using my slope, I'm going to count up 2 to the right 1, get a few more points on that line here. And then when we draw our line to connect those points, we can see that it looks something like that. And then we look for that point of intersection. We can see that they do intersect at our point here, 1, 3. So that is our solution to our system of equations for number 1. Alright, so slope-intercept form, very easy. We can use our y-intercept and the slope to graph. Well, what if we have something like number 2, where we have x equals 3 and y equals negative 2? Well, if we have x equals 3, hopefully we're recognizing that that means that we have a vertical line that passes through our x-axis at 3. So we're hitting right here at 3, 0, and we said that was a vertical line, so that's going to be going straight up. There's x equals 3. And then if we have y is equal to negative 2, there's our horizontal line passing through negative 2 on the y-axis. So let's draw that horizontal line. And then we can see our point of intersection at 3, negative 2. So again, we have one solution. All right, looking at number 3, reviewing when we are in standard form. Remember, you can find your x and y intercepts. So looking at our first equation, of x plus y equals -1, we can say our x-intercept is at -1, 0, and then our y-intercept would be at 0, -1. So we can plot those 2 points at -1, 0 and 0, -1. We can connect those 2 points with a straight line. Will look something like that. And then for our second equation, where we have x plus y is equal to 1, then we can say our x-intercept is going to be at 1, 0, and our y-intercept is going to be at 0, 1. So then we can plot those 2 points, 1, 0 and 0, 1. Connect those 2 points with a straight line. And then we can see that our lines are parallel. They're never going to touch. So this is an example of one of those where we will have no solution. Because they are parallel lines. All right, one more example, graphing by hand, and then we'll talk about how to use the graphing calculator. So for number 4, our first equation, it's in our wonderful slope-intercept form. So that first equation, we can see we have a slope of 3 and y-intercept at 4. Makes it super easy to graph. Y-intercept at 4, slope of 3, so up 3 to the right 1, and then we'll get another point up 3 to the right 1. And then we'll connect those with the line. So there's our first equation, y equals 3x plus 4. And then for our second equation, we have 4y equals 12x plus 16. So this is one of those equations that is in that other category for our linear functions. But it's very easy to put it into slope-intercept form by dividing by 4. So for our second equation, once we change forms, we can say that y is equal to 3x plus 4. So now I can see my slope is 3, my y-intercept is 4, which happens to be the same thing that we had before. There's our y-intercept at 0, 4. Using our slope, finding our y-intercept, or a couple more points using our slope with the y-intercept. And we can see that we're graphing on the exact same line. So this is one of those examples. They are the same line, so we would say infinitely many solutions. And then we're going to be specific and say that it's on the equation y equals, we'll use the first one that's in slope-intercept form, 3x plus 4. So that gives us an example of each of the scenarios, practice graphing from different forms, and reviewing our vertical and horizontal lines. Now, everybody wants to know, how can I use the graphing calculator to make this so much easier for myself? And it's going to be very easy. So let's pull up our graphing calculator here. And on our graphing calculator, we want to look and see. First, let's make sure the graphing calculator is on. Once your equation is in slope-intercept form, you can simply go to the y equals menu, and you can type in both of your equations. So looking at number 5, we're going to have negative x plus 4, and we're going to hit enter. And then we're going to type in our second equation, and that's going to be 2x minus 3. And then once we have our two equations, from here we can go and graph. And the graph feature, it's going to take you to that standard window going from -10 to +10 on each axis. You can of course go into the window or zoom features and change the view if you want to actually see where the lines intersect. With some of the newer calculators, you don't have to see it to have the calculator make that calculation for you. But now from here, if we hit the second, that yellow second key, and then trace button, that's going to take us into the calculate feature. And then if we choose option number 5, that's where we're going to find the intersection. And we are on the first curve, or that first line. We're just going to hit enter. Then it asks about the second curve. It jumped to our second line, so we'll just hit enter again. And then for the guess, we're going to let it do the guesswork for us. We're just going to hit enter one more time. And it's telling us where we intersect. And we're going to round to the nearest hundredth for this. So we're going to say it's about 2 33/100ths, and then 1 67/100ths. So let's write that information down. And then we also asked you to classify each system. I know this is something that was from years ago when you took Math 1, but just to review, those classifications were consistent and independent, and that's simply talking about your intersecting lines, which is what we had in the first example. Consistent and dependent, that's when you have the same line. So that's where you have infinitely many solutions. And inconsistent is where we have our parallel lines. There will be no solution for them. All right, so let's get some more practice here. Oops, and I deleted the answers, but that's okay. We just want to make sure that we can get a couple more examples in here where we can come up with our answers. So let's look at number 6. Let's go back into our calculator. And we're going to clear out the first equations that we had. And then let's type in what we have for number 6. So if we have our 35/100ths times x, and then we're going to subtract our 1 1200ths. And then for our second equation, we have our negative 2 2500ths x minus 4 500ths, or sorry, 5,000ths, 0 5. So once you type them in, all you have to do is say that I want it to graph. We can see that point of intersection. So our yellow second key and trace takes us into calculate. We want option number 5, and then we let the calculator do all the work. We're going to hit enter for the first curve, enter for the second curve, enter again for the guess, and we can see that we intersect at negative 1 1300ths, negative 1 5100ths. And again, that's showing that one point of intersection. So that means that we are consistent and consistent and independent. So we said this one was at negative 1 1300ths and negative 1 5100ths. And that one's consistent and independent. All right, so pretty easy when they're all in slope-intercept form. But what if it's not in slope-intercept form? So if we look at something like number 9, let's take this first equation here, and let's make sure that it is in slope and intercept form. So if we have x minus y is equal to 6, I'm going to make things a little bit easier here and, add the y to both sides. Let's scoot that over. And then subtract the 6. So taking care of everything in one big step, we have x minus 6 is equal to y. And then our second equation that we're going to plug in is y equals 9. So I want you to try that. Type in your y equals menu. Make sure you clear out the other equations. Type in for the first one, x minus 6. Hit enter. Your second equation, all you're doing is typing 9. When you go to graph, you should have a nice horizontal line for that y equals 9. You will see it there. You may need to change the window when you go to calculate, but you should come up with the answer of 15.9. Okay, so just to make sure, my answers disappear when I do that. We do want to save our answers there. But let's come in here and clear and make sure you can see those windows. So remember we said that our first equation was x minus 6. And I'm typing it in the second equation spot, but that's okay. We'll just go up to the first equation and say that we have y equals 9. We'll get the same answer. So when we graph, there's both of them. I can't quite see that point of intersection. So if it asks here, and you get the error that there's no sign change, then we're just going to go back and change our window. You can have it choose specific values for your x and y, or you can simply go to zoom and zoom out, or maybe zoom fit. But make sure you hit enter after you zoom out. Now that we can see that point of intersection, we can go back and tell it second trace. We want to calculate our intersection. Hit enter 3 times, and there's the answer that you should come up with, 15.9. Alright, we'll do one more where we're going to have to change forms. If we look at number 10, we can see that we're in standard form for both of these. So some extra practice changing from standard form to slope-intercept form. For this first equation, all we have to do is subtract x from both sides. So we have y equals our negative x plus 27. Then for the second equation, if we add y to both sides and then subtract 41 from both sides, we can take care of everything in one step. So that means that we're going to have y is equal to 3x minus 41. So I want you to type that into your calculator. Again, go into y equals, clear each of those equations out. First equation, y equals negative x plus 27. Your second equation, y equals 3x minus 41. Make sure you can see where it intersects. Again, if you have one of the newer calculators, you might not have to. But you can either go to window and change your x and y values for that window, or you can simply zoom out until you see the intersection. And now you're going to hit second trace. We went option number 5. Hit enter 3 times. And then you should come up with the solution of 1710. If you can't get that or have any questions, be sure to email or send me a remind message, ask in class. But hopefully we're good to go with solving systems of equations by graphing, and we'll talk about how to solve them algebraically in class tomorrow.